Good morning, sir.
Good morning.
Good morning, sir.
Hey, good morning. Okay, we'll start now. So yesterday we are in normalization. In normalization, we are following some rules that we call it as, each rule is called as normal form. In that, we have studied 1NF, 2NF, 3NF, right? Then we have to continue with the last rule called as BCNF, that is BIOS and called normal form. BCNF, BIOS.
Sir, audio is not clear.
BIOS, code, normal form. Right? BIOS code.
Sir, there is a lot of glitches in your
Sir,
audio, sir.
Maybe network problem it is. We'll wait for a second.
Excuse me, sir.
Yes. The audio is clear?
yes, sir.
Yes, sir.
Okay, it was a network problem, it was restarted. Okay, we'll continue. So BIOS code normal form. the BCNF is the higher version of third normal form, because this we are considering as fourth rule. So this is the higher version of 3NF. It means continuity eddies. This form deals with certain type of anomalies that is not handled by 3NF. The things which are not handled in 3NF are handled in this BCNF. A 3NF table which does not have multiple overlapping candidate keys is said to be in BCNF. In 3NF table which does not have the facility of handling the more than one overlapping candidate keys, that can be done in BCNF. When a relation has more than one candidate key, anomalies may result even though the relation is in 3NF. It means it is concentrating on multiple candidate keys. We are concentrating a multiple candidate keys overlapping in BCNF. Even though that table is in 3NF, but that may contain multiple overlapping candidate keys, means we are using BCNF. 3NF does not satisfactorily deal satisfactorily with the case of relation with overlapping candidate keys. What is the drawback of 3NF we are stating here? In 3NF, it does not deal satisfactorily with the, in case of a relation is having multiple overlapping candidate keys, it is not possible in 3NF. You cannot handle properly. It is composite candidate key with at least one attribute in common. It means the problem with the 3NF is it is not handling properly that satisfactorily. We cannot deal the multiple overlapping candidate keys that can be done in BCNF. BCNF is based on the concept of determinant. This rule is based on the concept of determinant. A determinant is any attribute on which some other attribute is fully functionally dependent. What is determinant? It is also an attribute on which some other attributes are completely depends. That we are calling it as determinant. Is it clear?
Yes, sir.
Next. Okay. Next topic is okay. Next one is relational algebra. Relational algebra. When you say an algebra in mathematics, also you have to follow certain rules to solve the or simplify the given expressions. Here also in relational algebra also we are doing same thing. To implement a DBMS, right? In order to implement the DBMS, we have to follow certain rules. How the database should behave, right? That can be decided by certain rules that we are discussing here. In order to implement a DBMS, there must exist a set of rules which state how the database system will behave. It means in DBMS also we have a group of rules, a set of rules using which we can state that how your DBMS system will behave. For example, somewhere in the DBMS must be a set of statements which indicate then when someone inserts data into a row of a relation, it has the effect.
Sir, your audio is not clear.
Again, it might be an
Yes, sir. Your audio is not clear. Please, sir.
wait for a second, then we'll start.
Excuse me, sir.
Yes.
Sir, your audio is not clear.
The problem is in the network.
Excuse me, sir.
There are a lot of glitches.
Yes. Is it clear now?
Yes,
Yes,
sir.
sir.
It was a network
Yes, sir.
problem.
Yes, sir.
Yes. Later, today again it is the network is under the problem. Okay, we'll start. Example, what we are stating. I'll repeat this. In order to implement a DBMS, there must exist a set of rules which state how the database system will behave. ಏನು ಮಾಡ್ತಾ ಇದೀವಿ? ನೀವು DBMS ಮಾಡಬೇಕಾಗಿದ್ರೆ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಬೇಕಾಗಿದ್ರೆ ಆ ಸಿಸ್ಟಮ್ ನಲ್ಲಿ DBMS ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ರಿ ಅಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಫಾಲೋ ಸರ್ಟನ್ ರೂಲ್ಸ್. ಆ ರೂಲ್ ಯೂಸ್ ಮಾಡಿ ಏನ್ ಮಾಡ್ಬೋದು? ನಮ್ಮ ಸಿಸ್ಟಮ್ ಯಾವ ರೀತಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ ಅಂತ ಡಿಸೈಡ್ ಮಾಡೋದು ಯಾವುದು? ದ ಸೆಟ್ ಆಫ್ ರೂಲ್ಸ್ ವಿಲ್ ಡಿಸೈಡ್ how your system is going to behave. For example, we are considering in the DBMS, if someone has inserted a data into the row of a relation, it has the effect which the user expects. One way to specify this is to use words to write an essay as to how the DBMS will operate. But words tend to be imprecise and open interpretation. Instead, relational databases are more usually defined using relational algebra. It means, in the example, it is stated that when someone adds a data into a row of a relation, this effect which the user expects. Correct? User is expecting something. One way to specify this is to use words to write an essay as how the DBMS will operate. How to operate the DBMS, how the DBMS operates, that you have to decide with the help of the set of rules which governs our DBMS systems. The last point you can understand that in relational databases usually defined using relational algebra, right? Then what is this relational algebra? We understood that there is a system in that you have to implement a DBMS by following certain rules, right? How your system is going to behave, that you understood. After that, what is that relational algebra is? The relational algebra is the formal description of how a relational database operates. It means we are describing, the relational algebra is going to describe how your relational database is operating, right? Casual operations, the formal description of how a relational database operates, that will be described by our relational algebra. An interface to the data stored in the database itself. The relational algebra is acting as an interface to the data stored in our database. This is the second point. The last point, the relational algebra is the mathematics which underpin SQL operations. The relational algebra uses SQL operations, that is structured query language operations, right? It underpins the structured query language operations. So this is about relational algebra. Shall I repeat this or shall I go for next? Okay, next. The operators in relational algebra are not necessarily the same SQL operators. We are using some operators in relational algebra. They are not same as the structured query language operators, even if they have the same name. Clear ಹೇಳ್ತಾ ಇದೀವಿ. In relational algebra, we have some operators. In structured query language, we have some operators. Even though in both the cases, the name of the operators are same, but their operations are different. Is it clear, this point? This point is clear.
Yes, sir.
We'll take an example. We are comparing here lesson number 13 and 14 here in this particular paras, right? The operators in chapter number 14, the name are same with the operators we are using in the relational algebra. Even though the name of them are same, but the operations are different. For example, the select statement exists in SQL. One of the name of the operator in SQL chapter number 14 is select. Select the statement exists in SQL and also exists in relational algebra. This statement is existing in both. Select ಅನ್ನೋದು ಎರಡು ಕಡೆ ಇದೆ. ಚಾಪ್ಟರ್ ನಂಬರ್ 14 ಅಲ್ಲಿ SQL ಅಲ್ಲೂ ಇದೆ. ಈ ಚಾಪ್ಟರ್ ನಂಬರ್ 13 ರಿಲೇಷನಲ್ ಆಲ್ಜಿಬ್ರಾದಲ್ಲೂ ಸೆಲೆಕ್ಟ್ ಅಂತಿದೆ. ಕರೆಕ್ಟಾ? These two uses of select are not same. ಎರಡು ಕಡೆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಪರೇಟರ್ ಹೆಸರು ಸೇಮ್ ಇದೆ, ಸೆಲೆಕ್ಟ್ ಅಂತಾನೆ, ಬಟ್ ಅದರದ್ದು ಯೂಸ್ ಏನಿದೆ ಬೇರೆ ಬೇರೆ ಇದೆ. The DBMS must take whatever SQL statements the user types in and translate them into relational algebra operations before applying them to the database. In DBMS, what happens? Whatever the SQL statement the user is going to enter, that will be translated into relational algebra operations before applying them into the database. That apply in the Modulo. In ಮಾಡ್ತಾ ಇದೆ ಇದು? It is the user instructions are they converted. Again, there was a network problem. Again, it is restarted. Is it clear? The network internet connection is not stable. Network is not stable. That's why it is restarting oftenly now. Is it audible to you all now? ಕೇಳಿಸ್ತಾ ಇದ್ದೀರಿ? Yes. Have you joined back?
Yes, sir.
Okay.
Yes, sir.
Sir, class is disconnecting, sir.
ಅದು ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಾ ಇದೆ, ಅದೇ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಫ್ಲಕ್ಚುಯೇಟ್ ಆಗ್ತಾ ಇದೆ ನೆಟ್ವರ್ಕ್. It is disconnecting again, automatically connecting also.
Yes, sir. Now I joined, sir.
Okay. ಎಲ್ಲರಿಗೂ ಅದೇ ಪ್ರಾಬ್ಲಮ್ ಬರ್ತಾ ಇದೆ ಇವತ್ತು ಮೋಸ್ಟ್ಲಿ ಮತ್ತೆ. Okay. We'll continue. I hope the theory part you understood now. I'll repeat once again. The relational algebra. In order to implement the DBMS, yes, again it happened.
Object is
Yes. I joined back again. Have you joined back? Okay. The relational algebra. To implement DBMS, you have to follow certain set of rules. Using that, you can state that how your database system will going to behave. Right? The relational algebra formally, it describes how the relational database operates. Then secondly, it acts as an interface to the data stored in the database itself. And lastly, the operators which we are using in relational algebra and SQL, right? The name of the operators may be same, but the uses of them may be different. After knowing this much, we'll continue with the terminologies, the terms used in relational algebra, that we're calling it as terminology. First term, relation. What is a relation? A set of tuples. A set of tuples is called as a relation. Then second, what is a tuple? A collection of attributes. A collection of attributes which describe some real world entity. What is a tuple? Tuple is a collection of attributes which describe tuple is a collection of attributes which describe some real world entities. A collection of attributes which describe some real world entity is called as tuple. Then attribute. A real world role played by a named domain. What is an attribute? Attribute is a real world role played by a named domain. Then what is domain? Domain is a set of atomic values. A set of atomic values, individual values, small values are called as domain here, set of values. Then what is set? A mathematical definition for a collection of objects which contains no duplicates. What is set? Set means, according to mathematics, mathematical definition, it is a collection of objects, collection of unique objects. We are calling it as a set. See here. What is set? Set, according to mathematical definition, set is a collection of unique objects. Collection of unique objects is called as set. Then what is domain? A set of atomic values is called domain. Then what is attribute? A named domain is an attribute. Then tuple, a collection of attributes which describes then next we move on to relation. A set of tuples is called a relation. Then we'll start learning the operators used in relational algebra. First, the operators right we'll study. In that, the first operator is insert. Insert. It provides a list of attribute values for a new tuple in a relation. This operator is same as SQL. What it does? The insert provides a list of attribute values. It means for all the attributes we are entering some values. It is nothing but adding the values for all the attributes. That creates a one new tuple. We are entering the tuple values. We are entering the attribute values. It means that is nothing but a tuple. Collection of attribute is a tuple. That's why we are saying that insert is inserting, adding the values to the attributes. That creates a new tuple. This is same as what we are studying in SQL also. In relational algebra as well as in SQL, the operator insert is functioning is same. Here also it inserts, there also it inserts. It inserts the data into the respective attributes. That creates a new tuple. Is it clear? Then next, second operator, delete. This provides condition on the attributes of a relation to determine which tuple to remove from the relation. This operator is the same as SQL. Again, delete operator. This operator is also performing the same thing in both the cases. In relational algebra as well as in SQL, this performs the same operation. What it does? The delete operator is used to remove the unwanted, right, tuples from a relation based on certain condition on the attributes. Suppose think that I want to delete some tuple or one tuple from a student database. What I'll do is, based on one attribute I'll take. That is, I'll take the remarks column. List the students or delete the students whose values are fail in remark column. ಅಂದ್ರೆ ಏನ್ ಮಾಡಬೇಕಾಗಿದೆ, ಆ ರಿಮಾರ್ಕ್ ಕಾಲಮ್ ನೋಡಿ ನಾನು ಡಿಲೀಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇನ್ನ ಮೇ ಬಿ ಒನ್ ಟಪಲ್ ಆರ್ ಮೋರ್ ದೆನ್ ಒನ್ ಟಪಲ್, ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಹೋಗುತ್ತೆ. ಜಸ್ಟ್ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಒನ್. ಯಾರ್ ಸ್ಟೂಡೆಂಟ್ ರಿಮಾರ್ಕ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಫೇಲ್ ಅಂತಿದಾನೋ ಅವನ್ನೆಲ್ಲ ಡಿಲೀಟ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ಅಟ್ರಿಬ್ಯೂಟ್ ಐ ಆಮ್ ರಿಮೂವಿಂಗ್ ದ ಕಂಪ್ಲೀಟ್ tuple of that student. Andre complete one record will be deleted. All the attributes values will be deleted. Based on what? Based on the condition given on the column called as remarks. Is it clear? Insert add ಮಾಡ್ತಾ ಇದೆ, delete ಮಾಡ್ತಾ ಇದೆ. The uses of both are same in both the cases, in relational algebra as well as SQL. We go for third one, modify. Modify means changes the values of one or more attributes in one or more tuples of a relation as identified by a condition operating on the attributes of the relation. This is equivalent to the SQL update. What are you doing it here?
Oh.
So, modify is the third operator in this. Modify means making changes. Where you can do the changes? You can change the values of one or more attributes in one or more tuples of a relation. ಒಂದು ಅಥವಾ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ರೆಕಾರ್ಡ್ಸ್ ಅಲ್ಲೂ ಕೂಡ ಚೇಂಜಸ್ ಮಾಡಬಹುದು. ರೈಟ್, ಒಂದೇ ಅಟ್ರಿಬ್ಯೂಟ್ ಅಲ್ಲಿ ಮಾಡಬಹುದು ಅಥವಾ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಅಟ್ರಿಬ್ಯೂಟ್ ಅಲ್ಲಿ ಮಾಡಬಹುದು. ಆರ್ either you can make changes in one tuple or more than one tuple of a relation. Correct? This can be identified by a condition operating on the attributes of a relation. Based on the condition of particular attribute, you can make the changes into the tuples in a tuples of a relation. Again, this modify in relational algebra is same as the update command in SQL. In SQL, this modify is part of one of the option in update command in SQL. It means again both are matching here. Relational algebra modify is same as SQL update. The uses are same. It means when you go through this insert, delete and modify, these are the same uses even in SQL. Insert means addition, adding the values into the respective tuples to create a new tuple in a relation. Then delete, based on the condition of particular attribute, you can delete the relation, delete the tuple from a relation. And modify is allowing you to make the changes in one or more attributes, in one or more tuples of a relation. Again, these three are same meanings, are same uses in even SQLs. Any doubt concerned to these three? Insert, delete, modify.
No, sir.
Next one. Let's start with operators called as retrieval. The operators retrieval. There are two groups of operations here. One is, first one, mathematical set theory based relations based on mathematics, mathematical set theory. So in that the terms used is union, intersection, difference and Cartesian product. These are the terms used in a set theory of mathematics that we are studying here. And the second category is special database operations. Second category is special database operations that contains select, project and join. Select, project and join. Right? In the retrieval operators, there are two groups of operations we have. One based on mathematical set theory based, union, intersection, difference and Cartesian product. And the second group is called as special database operations like select, then project and join. But clearly we are mentioning that the select operator in relational algebra is not same as the select in SQL. Both the uses are different here. After knowing that two headings, the next one is relational select. We're starting with select. Relational select of relational algebra. Select is used to obtain a subset of the tuples of a relation that satisfy a select condition. Select means as usual, general meaning only. We are selecting. What we are selecting? Something we are selecting. From where? From some database table. We have to put the condition. What we are selecting based on this condition. I want to see this information from this table. It means there must be a condition, so that based on that condition, that you have to get the information of that database tuples. The select is used to obtain subset of the tuples. It means there is a tuple, there is a record. Based on your condition, you get the information about that tuples. Maybe some attributes or all the attributes. Based on the condition, you get the particular view. For example, to find the all employees born after 14th February 2014. The question is, we want to list, we want to display the employees who are born after 14th February 2014. E date ಆದ್ಮೇಲೆ born ಆದವರದಷ್ಟೇ ಲಿಸ್ಟ್ ಬೇಕಾಗಿದೆ ಫ್ರಮ್ ಎಂಪ್ಲಾಯೀಸ್ ಡೇಟಾಬೇಸ್ ಇಂದ. ಎಂಪ್ಲಾಯೀಸ್ ಹೆಸರು ಬೇಕಾಗಿದೆ, ನನಗೆ ಎಲ್ಲ ಡೀಟೇಲ್ಸ್ ಬೇಕಾಗಿದೆ. ರೈಟ್, ಯಾರ್ಯಾರು ಎಂಪ್ಲಾಯೀಸ್ 14 ಫೆಬ್ರವರಿ ಆದ್ಮೇಲೆ ಬೋರ್ನ್ ಆದವರು ಇದಾರೆ ಅಂತ ನೋಡ್ಬೇಕಾಗಿದೆ. ಸೊ ಅದಕ್ಕೆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಯಾವ ತರ ಬರೀತೀನಿ ನಾನು ಇಲ್ಲದನ್ನ, select is the operator, then condition we are putting it down. DOB, based on what we are going? Based on the attribute called as date of birth. What date we want? That you have write it here. 14th February 2014. This is the condition we are putting. This date ಆದ್ಮೇಲೆ ಬರ್ತ್ ಆದವರು ಯಾರು, ಬೋರ್ನ್ ಆದವರು ಯಾರಿದ್ದಾರೆ ಅಂತ. ಎಲ್ಲಿಂದ? ಈ ಟೇಬಲ್ ಇಂದ. ಯಾವುದು? ಎಂಪ್ಲಾಯೀಸ್ ಅನ್ನೋ ಡೇಟಾಬೇಸ್ ಟೇಬಲ್ ಇಂದ. Select all the employees, those who are born after 14th February 2014 from a table called as, or a database called as employee. Employee table ಇಂದ 14th February 2014 ಆದ್ಮೇಲೆ ಯಾರ್ಯಾರು born ಆಗಿದ್ದಾರೆ ಅವ್ರದ್ದೆಲ್ಲರದು ಲಿಸ್ಟ್ ಬರುತ್ತೆ. That we are using with the help of this select. Is it clear? Select. Select ಅರ್ಥ ಆಯ್ತ್ರಿ? Select is clear?
Yes, sir.